Welcome back to school. Hope you had a great spring break. Today we're going to pick up where we left off with our discussion of conic sections. Before we left on break, we talked about two of the conic sections, the circle and the ellipse. Remember, conic sections are formed by taking a plane, so think like a slice or a sheet of paper, and slicing it through a cone. So here I have two cones, one on top of the other, and where they meet is called the nape. That like the nape of your neck. And so that's just a fun vocabulary word for all of you academic bowlers. If I take a slice of paper or a sheet of paper and slice it through one of the cones, and I hold that plane or that slice of paper parallel to the base or parallel to the horizontal, I get a circle, but when I put it at a diagonal and slice it through, then I get an ellipse. So a circle and an ellipse are very closely related. Today we're going to take a look at the hyperbola though. So a hyperbola happens when you take a plane and you slice it through two cones. Really, a hyperbola is a couple of parabolas that are joined by a common vertex, some vertices, or that's the plural of vertex, and some foci, which is the plural of the word focus. So I'm going to pull up Desmos now, and I'm going to turn all of these off just a second. I have a circle graphed. And as you can see, the circle has a center at -2, 3. Look at the equation, -2, 3. Yep, that center makes sense. Over here it equals 9, and the square root of 9 is 3. Remember, that gives you the radius. So from my center, can I go out 1, 2, 3? Yep, up 3, down 3, left 3. In fact, if I go 3 units from the center all around this region, I form that circle. Now, up in green comes an ellipse. So the ellipse and the circle have the same center point, -2, 3. They both are the addition of these two squares, x squared and y squared. Underneath the x squared part, I put a 25, and underneath the y squared part, I put a 9. The square root of 25 is 5. So from the center, I'm going to go to the left 5, and I'm going to go to the right 5. Underneath the y squared part is a 9. Square root of 9 is 3. So from the center, I'm going to go up 3 and down 3. So that's how I drew my ellipse. The ellipse and the center, or the circle, have the same center. The ellipse is oriented horizontally, though. So if you're talking about the orientation of an ellipse, you're talking about, is it more lefty-righty or is it more uppy-downy? Those aren't really words, but you know me. So because the bigger number is underneath the x squared part, so 25 is obviously larger than 9, and it's underneath x squared, that's how I know without looking at the graph that this ellipse is going to be oriented horizontally. All right, so let me show you something cool here. Ta-da! Up comes a purple hyperbola. So on the graph, you see the circle and then the ellipse and then the hyperbola in purple. So if I look over here on the left, the equation of the ellipse and the equation of the hyperbola are very similar. The only thing that's different is the ellipse has addition and the hyperbola has subtraction. So the x squared part is positive. That's how I know that the hyperbola is going to be opening to the left and to the right. Wait a minute, what's this opening business? So the ellipse here in green, I always think of a hyperbola as just a filleted ellipse. If you've ever been fishing and you catch a fish and then you want to eat it, you fillet a fish. When you fillet a fish, you slice it along its backbone and just like open it up. So that's what we've done here to this ellipse. We've sliced it along this vertical line of symmetry and just peeled it open. So hyperbola is just an ellipse sliced open. Since x squared is positive, it's going to be opening to the left and to the right. Now check out, ta-da, red hyperbola. This time the y squared part is positive, and so I've filleted this green ellipse, I've filleted open up and down. Well, I'm going to turn that off for a minute, and let's talk about the green and the purple again. So back to these equations on the left, again, very similar. The only thing that's changed is one is addition and one is subtraction. So to graph this hyperbola, I started at my center, -2, 3. And then I know that it's going to be opening to the left and to the right because x squared is positive. So pretty simplistically, I just went to the left and to the right 5 and ka-chow, 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 graphed some parabolas opening to the left and to the right. Same idea if I wanted to graph it vertically opening up and down from my center. Since the 9 is positive, I mean the y squared is positive, the square root of 9 is 3. So from the center, I go up 3 and I go down 3. And that gives me my vertices, and ta-da, that's how I would make my very rough, sketchy sketch of that hyperbola. Let's see. Whoa. I think that's about all I have to say about that. Another piece of vocabulary that we're going to talk about is the transverse axis. So the transverse axis, if I turn off my ellipse, and I'm actually going to turn off the center or circle as well. Okay, so on this hyperbola, the transverse axis is the distance from your vertex to your other vertex crossing through the center. So on my next screen, I'm going to plot these vertices so you know a little bit more about what I'm talking about. The transverse axis, again, though, in this case would be 6. 1, 2, 3, 4, 5, 6. If I turn that one off and I bring up my, oh, that's wrong. Turn that one off and bring up my hyperbola that's opening to the left and to the right. Now this guy is going to have a transverse axis of 10. So the square root of 25 was 5. From the center, I went to the right 5 and I went to the left 5. The length of the transverse axis is going to be 2 times 5, or 10. It's just the length of the distance from vertex to vertex crossing through the center point. All right, a couple more graphs. So I have up here a hyperbola that's opening to the left and to the right. And as you can see, my center point would probably be, oh, I don't know, let's split the difference here, probably about 1, -2. Oh yeah, that makes sense. Look up here. Equation, x value would be 1, y value would be -2. Counterintuitive, opposite of what you would think, but it makes sense if you think about the zeros of both of these, x minus 1 factor, y plus 2 factor. All right, so anyway, I don't have it plotted. I could if I wanted to, but we get the idea. Over 1, down 2. Now, x squared is positive, so I know that it opens to the left and it opens to the right. From the center, how did I get my vertex? Well, my center was 1, -2. The distance is going to be the square root of 16, or 4, in the horizontal direction. So 1 plus 4 down 2 gives me a vertex right about there. Then, same idea, but 1 minus 4. So from the center, subtract 4, or go to the left 4 units. Ta-da, there's my other vertex. Now, foci, or focuses in plural, are other important parts of a hyperbola. If I could see you in person, I'd show you a really cool trick on how to graph a hyperbola using a piece of string and a couple of thumbtacks, but maybe someday soon I'll get to see your lovely faces. I miss you all so much. Anyway, let's talk about foci and pull ourselves back together. Okay, so a focus is found from the center, C units in either direction, depending on the direction of the opening. All right, 65, square root 65. Where am I getting these numbers? To get that focus number, you take a squared, which is 16, and you add it to 49, which is b squared. 16 plus 49 is 65. Take the square root of it, and that's how you get the location of your foci. So again, you take your center, you decide, are my foci going to be left and right of the center? They will be if you're opening to the left and to the right. Or will they be up and down? And they will be up and down if your vertexes are up and down, or if your y squared part in your equation is positive. Okay, so anyway, I took 1 plus the square root of 65, and then I went down 2. There's one of the foci. Same drill, 1 minus the square root of 65 and go down 2. That gave me my second focus, or one of the foci. So I'm going to go back to my document here, and I've got this this diagram here that kind of puts all of the vocabulary in one place for us. So here's a hyperbola opening to the left and to the right. Smack dab in the middle is the center. The transverse axis connects our two vertices, vertex, vertex. And then our foci, or focuses, also lay on like an extension of this transverse axis. We're not going to do anything with the conjugate axis and the covertex. That's not all that important right now. But as you can see, these two parabolas that make up the hyperbola, they seem to be hugging these asymptotes, asymptotes. Here is another look at the same kind of idea, depending on how you're oriented. Not oriented, how you're going to be opening. X squared is positive, so I open to the left and to the right. Y squared is positive, so I open up and down. I liked this picture though, because it also shows you these asymptotes. So these asymptotes will always cross through your center point, cross through your center point. And it's a really simple equation. They're linear, so their equations will look like, y equals mx plus b. And so you just take y equals negative b over a, and then y equals positive b over a, and then times x. All right, I'm going back to Desmos. Ready? Here we go. Okay, so here's one of my asymptotes, and ta-da, there's the other asymptote. I suppose I could probably make those dotted. I should do that next time. So how did I come up with the equation of these asymptotes? How did I know where to draw them in on Desmos? Well, go back to your original equation. X minus 1 and y plus 2 were those two factors that gave me my center point. So there's x minus 1 and y plus 2. That just came straight out of my original standard form of that hyperbola. 7 and 4, 7 over 4 in the positive version, 7 over 4 in the negative version. So the positive 7 over 4 gives me the increasing asymptote. 7 over 4 as a negative gives me this decreasing slope asymptote. Again, where'd the 7 and the 4 come from? Well, 7 is 49's square root, and 4 is 16's square root. So whatever is under your x is always going to be a, or a squared. Whatever is under the y will always be your b squared. That's where you're going to get your b. All right, so I think that's all I have to say about this graph. If I went back to one of these graphs right here, I have this guy. I'm going to do the up and down one. Okay, so what I'm going to do now, just for the heck of it, I am going to type in the asymptote. So I start with y minus 3 equals, and then I'm going to do the positive slope. So let's see, b will be 3 over a will be 5. And then my x is x plus 2 because the center is shifted to the left too. Yep, that blue line is sure a hugger. And then the other version will be y equals negative. Again, it's b, so the square root of 9 is 3 over a, which is the square root of 25 or 5. And then x plus 2 shifted the whole kit and caboodle to the left. And there's that green asymptote. The negative slope, again, that asymptote, asymptote is being hugged by those two parabolic curves that make up the hyperbola. All right, so I know that I've thrown a lot of information at you super fast. I sure wish I could see your faces of confusion, or maybe they're faces of pure delight because your brains are being used again and you're so happy to hear the sound of my bird-like voice. Just kidding. You know me. I'm a kook. Anyway, in the Google Classroom, you will find a document that's got more notes and then 3 homework problems that I'd like you to take a look at. So for your homework, what I need you to do is use your very best completing the square skills to get the equation into standard form. So in other words, something like this. And then I want you to try your very best to identify the center and the vertices and the foci, and maybe even you can give me some vertices, or no, I'm sorry, asymptotes. Give me those hugging asymptotes. So see what you can do. We'll meet up again tomorrow and spend a little bit more time on maybe if I just gave you some of these things, could you do the graphing and could you develop an equation all by yourself? So tomorrow we're going to kind of work backwards from what we're doing today. All right, hope you're all doing well, and I look forward to seeing your work. And let me know if you have any questions. Email me. I'm around. Take care. Bye, guys.